Hey, what's up? John Sonmez from SimpleProgrammer.com. So I got this question from Moritz about when to basically build a smaller or large solution. Really, we could read the word hack in here, when to hack it out, or a kludge. He says, thanks for your podcast. I enjoy listening to them on my commutes and resonate with a lot of them. My question for you, how do you decide when to build a small or minimal solution and when to build a big one? I'm developing internally used applications, and we often get feature requests that could be solved with little effort, but the solution is very specific to the problem and maybe hacky, and maybe it'll come back later to bite us. And then there are more general solutions that are often more effort, but feel more consistent and maybe solve some related problems too. But there isn't time to build the big and quote proper solution for each feature request. How do you decide where to invest your time to make the most impact? Cheers, Moritz. So this is sort of a tough one. This is kind of an age-old software development question of whether or not you write the hack, you do the shortcut, or you build the big solution. Also, it reminds me of the whole over-engineering type of question that we often get, right? So there's not really like a definite answer to this. Right? I hate to say it depends, but it depends on context, right? This is something that's really important to understand, is that sometimes it's going to be right to do the solution that is going to just get you through the day, right? So I'll give you a context where you actually need to go to the production server and make a hack. Let's say that you are a startup and you're launching your product, and if you do not sell this product, tomorrow you will be gone and everyone will be fired. In that case, you don't care about doing the right things. You don't care about maintaining. You just got to get it working now and today because the site is down, right? In that case, you just do whatever is required to get that done, right? So that's a possible context, right? Here's another context. Let's say the context is that you're working on a medical device that is going to keep someone's heart beating, okay? And you have a bug in it. Well, you don't want to just patch that real quick and get that working, right? You want to build a more robust solution and make sure that it's tested well and designed well and planned out, and maybe, a lot more going on there, right? So that's another context. There's all kinds of contexts in between that, right? But you got to think about this. Now, as far as like just let's say that you have sort of the middle of the road where you just have a problem and you're trying to decide how should you solve this problem. Should you like write something that's specific to that problem, or you should write something that's more general? Well, you want to err on the side of writing something specific to the problem, because as human beings, we're really bad at predicting the future. We don't know what we're going to need. So what we can end up doing is we can end up packing. I mean, have you ever done this? Like, I go on a flight and I pack my backpack here. I got my backpack, right? And I will pack it with like, oh, here it is. These things, right? These are like, I'll pack like 2 of these. These are like cell phone chargers. These are like, I don't know how many. It's 10,000 milliamps, right? So I pack 2 of these things, and I pack all this stuff that I'm not going to need because I think, well, maybe my cell phone will run out of juice. It never does. I never actually use any of those things, right? I pack all these cables and cords, and I never use any of them because I'm not good at predicting what's going to happen. And then you know what happens? The one thing I didn't pack, that's the crap that I need. That's the thing, because I can't predict that ahead of time. Like, I'm not saying not to be prepared, but we're bad predictors. So stop trying to predict. And what ends up happening in software development when you over-predict is you over-engineer it. You build this whole big solution, you build this whole framework, you're like, look at these parts, I can swap this thing out, and if this whole system changes, if we use a different database, this will still work. We can just change this one thing. And none of that stuff ever happens. Instead, the one little thing you didn't account for comes in and blows up in your face. So my advice in those situations is you fix the problem, you don't hack it, you don't kludge it, you do a good job of fixing the problem, but you fix it specifically for that problem. And then when the problem comes up again, or you see a variation of it, then you go and you design something that's going to be a little bit more generalized. And then if it comes up again, more generalized. And you expand out there, because you don't build stuff you don't need until you know you need it. So, another way of looking at this is, I talk about, like in C# or Java, like specifically in the language, I say that you don't need an interface until you have more than one implementation, right? And a lot of people disagree with that, but I think that's totally true. Like, you know, I know that it goes against the whole mocking frameworks and test-driven development and whatnot, but honestly, like from a design, purely design perspective, unless you have more than one implementation, you don't need an interface. And when you take that to the next level, unless you have multiple implementations that you're swapping out at runtime, you don't need a dependency injection. Unless you have multiple dependencies that you're actually swapping the injection of, you don't need them. Now, I know that we do it for test-driven development and architecture and stuff, but when you get down to the bare roots of design, that's the best approach. You don't over-engineer. So, you know, we got to be pragmatic, and I understand being pragmatic. So I'm not saying that you have to, you know, totally subscribe to that philosophy. I do when I write code now, but you don't have to. But the point is just, you know, you got to balance things out and just try not to, don't think that you're going to predict things correctly, because you can't. So err on the side of fixing the thing specifically for the problem, because it's going to take less time, it's going to take less resources, and you're going to get your predictions wrong anyway. And then as you learn and adapt, then you generalize out more, and then, you know, eventually you get a robust solution. But it's robust based on actual reality, actual field testing, rather than robust based on this imaginary world that you've constructed in your head of what you think is going to happen. So great question. Thanks for sending it. If you've got a question for me, you can email me at john@simpleprogrammer.com. And if you like this channel, subscribe. Take care.